Hello everyone, my name is G. Shankar Bhaskar, Associate Professor in Department of Electronics and Communication Engineering, Srivasu Engineering College, Pedatadipalli, Tadipalligudam. Today I will discuss about this electromagnetic waves and transmission lines. Mainly the basic concept of the first of electrostatic field. Second one is magnetostatic field. Magnetostatic field is what is a magnetic field? The magnetic field What is magnetic field? The magnetic field, the region around the magnet, that region is called a magnetic field. What is the region? The region around that magnet, there is North Pole and South Pole. The one is North Pole, another one is South Pole. There is the North Pole to South Pole, the number of lines will flowing from North Pole to South Pole. This is the region. This is the region. This is the region. The number of lines are flowing from North Pole to South Pole, that lines is called the flux lines. The number of lines will flowing from North Pole to South Pole, that lines are called flux lines. The number of flux lines will generate, the number of lines will be generate a magnetic flux. That flux will be denoted as psi. Therefore, the magnetic lines, the flux is representation as units is Webers. The magnetic flux psi units is Webers. Therefore, 1 Weber is equal to 10 to the power of 8 lines. Very, very important. The number of lines will flowing from North Pole to South Pole. The 1 Weber is equal to 10 to the power of 8 lines. Next one, you have to define a magnetic field intensity. Magnetic field intensity. The magnetic field intensity denoted as a capital H. The units is Newton per Weber or Ampere per meter. Ampere per meter. What is magnetic field intensity? The magnetic field intensity is defined as the ratio of the force per unit North Pole of Webers. North Pole of flux in Webers is called the magnetic field intensity. The units is Newton per Weber or Ampere per meter, is also defined in terms of a current in terms of a line, therefore Ampere per meter. Ampere per meter. Next, you have to define for a magnetic flux density, the magnetic flux density, the denoted as B. The magnetic flux density is directly proportional to magnetic field intensity, H. Therefore, the proportionality, the magnetic field intensity, you have to, proportionality is eliminated. There is nothing but directly you have to constant. That constant is mu. B is equal to mu H. B is equal to mu H, where mu is permeability. Permeability. Therefore, mu is equal to mu naught, mu r, where mu naught is equal to absolute permeability and mu r is equal to relative permeability. Relative permeability, where mu naught is equal to 4 pi into 10 to the power of minus 7 Henry per meter. Henry per meter. Therefore, what is defined as magnetic field intensity, magnetic flux density? The magnetic flux density is defined as, therefore, the magnetic flux per unit surface area. Therefore, magnetic flux units is Weber and surface area units is meter square, Weber per meter square or Tesla. Therefore, magnetic field flux density B is equal to psi by S. Therefore, we also defined the B simply. We also defined the magnetic flux density B is equal to d psi by ds. D psi by ds. Also, units is the Weber per meter square or Tesla. Tesla. This is the basic concept of the magnetostatic field. This basic concept you have to define. You have to derive the expression for Biot-Savart's law. The Biot-Savart's law. The Biot-Savart's law. In Biot-Savart's law, this is a conductor. This is a conductor. The current through the carrying element I is a differential element dl. The current is I into dl. Therefore, at a point P, you have to calculate a differential magnetic field intensity dH. The distance of this point to this point, the distance is R. Therefore, the unit vector AR, thus the angle is theta. There is a conductor filament. This straight the current carrying conductor, the current is flowing, this line is I. Therefore, the current element is DL. Therefore, the elemental current is I into DL. Therefore, I into DL, that point you have to calculate a point P, have to DH. Differential magnetic field intensity DH. But according to Bayes-Savage's law, therefore, the differential magnetic field intensity DH directly proportional to current through the element, therefore I into dl, and also directly proportional to 1 by square of the distance between them, therefore is also defined in terms of a dh is equal to the angle of the sine of the angle between the current element and the point P. Therefore, overall the conjunction of the electric field differential magnetic field intensity dh is directly proportional to ideal sin theta by r square. Therefore, the proportionality is eliminated. Therefore, some constant will be there. K ideal sin theta by r square. Where K is a proportionality constant. K is proportionality constant. Thus, proportionality means the 1 by 4 pi. Therefore, dh is equal to ideal sin theta by 4 pi r square. 4 pi r square. Therefore, this one, you have to representation of dh. Therefore, I, dl, magnitude of dl. The one another, the magnitude ar and sin theta by 4 pi r square. The magnitude of ar is along with the unit vector, the magnitude is unity. Therefore, ar is equal to 1. Have to 1 in the replace with the magnitude of ar. Therefore, dl magnitude, ar magnitude, sin theta by 4 pi r square. But we know that a cross b is equal to magnitude of a, magnitude of b, sin theta. Therefore, in this one, therefore dl cross ar is equal to dl magnitude, ar magnitude, sin theta. In the place of dl ar sin theta, you have to replace with dl cross ar. Therefore, the above equation you have to substitute this one. Therefore, dh is equal to I dl cross ar by 4 pi r square. 4 pi r square. This equation is also representation. Therefore, ar is equal to r by magnitude of r. Therefore, you have to replace with ar. Therefore, differential magnetic field intensity ideal cross r by 4 pi r cube. Therefore, units is the Newton per Weber or ampere per meter. Ampere per meter. In terms of a, therefore, a differential element, therefore, H is equal to, it is a line integral I dl cross r by 4 pi r cube. Therefore, ampere per meter for line charge. For a line current. For a line current. There is a distribution of current elements in magnetostatic field. There is a line current, surface current, and volume current. In the line current, therefore, ideal cross r by 4 pi r cube, ampere per meter. For a surface current, H is equal to the surface integral of k ds cross r by 4 pi r cube, ampere per meter. The surface current. But it is volume current. It is volume current. You have the representation. H is equal to the volume integral of j dv cross r by 4 pi r cube, ampere per meter. Ampere per meter. But what is line? It is also indicate that is a line. There is a line current. It is a current carrying element I. That is the element dl. The current is I into dl. What is surface? It is nothing but a surface. It is k into ds. It is volume. It is a volume. It is a representation of a volume. There is an element. There is nothing but element. You have to representation as j into dv. This is line. This is the surface. This is volume. Therefore, I into dl is equal to k into ds is equal to J into dV. Therefore, line current, surface current and volume current have to replace with ideal KDS, therefore surface current. Therefore, replace with ideal JDV, it is a volume current. Volume current. This is the line charge distribution in magnetostatic field. Magnetostatic field according to Biot-Savart's law. According to Biot-Savart's law. This is the basic concept of the Biot-Savart's law. You have to derive the expression for magnetic field intensity. It is very typical. I have to these application by using you have to different applications. First one is the magnetic field. The magnetic field due to straight filamentary conductor. Straight filamentary conductor. This is the one of the main applications of according by using Biot-Savart's law. You have to determine the magnetic field intensity at a straight filamentary conductor. A straight filamentary conductor, you have to represent this in a straight line. It is origin point 0. This along with y-axis. This is the point P. You have to determine dH. It is a straight line. In the straight line, the one point is A. Another point is a differential element dl. Another point you have to represent as a B. Therefore, z-axis, y-axis, it is nothing but x-axis. This one. Therefore, in this one, there is a origin point to the along with z-axis, the representation of z. The subtended angle of A, alpha 1. The subtended angle of differential element alpha. The subtended angle of differential element B, alpha 2. Therefore, the differential element to point P, the differential magnetic field intensity, the distance is R. The origin point to the point P, the distance is rho. First of all, you have to find out a magnetic field intensity, dH, at point P. But what is the current element? The current element, along with z direction. Along with z direction. The flowing of current I along with dl. Therefore, I into dl. Therefore, the magnetic field according to Biot-Savart's law. According to Biot-Savart's law. Therefore, the magnetic field intensity dH is equal to IDL cross AR by 4 pi R square Newton per Weber or Ampere per meter. It is also defined R. Therefore, H is equal to, dH is equal to IDL cross AR, R by 4 pi R cube. First of all, you have to find out DL. DL cross R. In DL cross R, here differential element along with z direction. It is a straight filamentary conductor along with z direction. Therefore, the differential element DL is equal to, that element is dz az. That is the first point. The equation number 1, the equation number 2. But what is R? Where R is equal to, this is the origin point, this is the differential element along with the point P. It is a straight filamentary conductor along with the origin point to DL. It is a how to point origin point to the differential element DL, that is the representation as a rho. Therefore, along with the R, rho, A rho minus Z Az, that is the equation number 2. Equation number 3. But what is R? Therefore, magnitude of R is equal to rho square plus Z square whole power 1 by 2. Therefore, these values you have to substitute this equation automatically by using the subtended angles. Therefore, you have to find out a cot alpha. Therefore, the cot alpha is equal to adjacent side Z by opposite side rho. Therefore, Z is equal to rho cot alpha. Therefore, differentiating both sides. Therefore, dz is equal to minus rho cosecant square alpha d alpha, equation number 4. Therefore, differential dz. Therefore, minus rho cosecant square alpha d alpha. And cot alpha, I have to differentiate minus cosecant square alpha d alpha. Therefore, substitute this equation. Therefore, dh is equal to I dl. What is dl? dl cross r. First, you have to find out dl cross r. dl cross r is equal to, therefore, a rho, a phi, az. First, you have to dl component. The dl component it is representation as only Az. Therefore, only Az, it is nothing but dz 0, 0. But only R component, there is R component, arrow component, the arrow component, it is rho. Therefore, Az component, it is minus z, it is 0. Therefore, you have to find out the dl cross R. Therefore, dl cross R is equal to this one. You have to find out the det. Therefore, first of all, arrow component is 0. For the minus a5, the a5 component, you have the representation of 0. Therefore, minus rho dz. Last, you have to component az component. Therefore, 0. Only you have to dz components are appear. Therefore, rho dz a5, rho dz a5. Therefore, dl cross r is equal to rho dz a5. This is the equation number 5. You have to substitute this equation number 1 and equation number 5. Therefore, equation number 5, substitute equation number 1. The differential element dl is equal to I. dl cross r is equal to rho dz a5 by denominator, it is r rho square plus z square whole power 3 by 2 whole power 3 by 2 4 pi rho square plus z square whole power 3 by 2. Or what is z? Therefore, dz is equal to minus rho cosecant square alpha d alpha. You have to substitute this equation. Substitute this equation. Therefore, we know that z is equal to rho cot alpha. Therefore, dz is equal to minus rho cosecant square alpha d alpha. Therefore, substitute this equation. Therefore, dh is equal to I by 4 pi. Therefore, rho dz. Therefore, minus rho cosecant square alpha d alpha a5 by rho square plus z square means rho cot square alpha whole power 3 by 2. Therefore, the differential magnetic field intensity dH is equal to I by 4 pi. I by 4 pi. I by 4 pi, this representation as minus rho square cosecant square alpha d alpha by this one, there is a rho square will be common. Therefore, rho square 1 plus cot square alpha whole power 3 by 2 a5. Therefore, my aim is the differential magnetic field intensity. Therefore, H is equal to integral I by 4 pi integral minus rho square cosecant square alpha d alpha a5 by, therefore, rho square will be common in denominator. Therefore, rho square, the cosecant square alpha whole power 3 by 2. Therefore, 1 plus cot square alpha is equal to cosecant square alpha. Therefore, rho square cosecant square alpha whole power 3 by 2. Therefore, square will be cancelled. Therefore, H is equal to I by 4 pi integral. You have to minus this one rho square cosecant square alpha d alpha by rho cube cosecant cube alpha a5. You have to cancel rho square, rho cube, a rho, cosecant square, a cosecant alpha. Therefore, H is equal to minus I by 4 pi rho integral 1 by cosecant alpha d alpha a5. Next one, you have to implement, you have to integrate the 1 by cosecant alpha is equal to sin alpha. Therefore, H is equal to the magnetic field intensity at point P is equal to minus I by 4 pi rho, the integral sin alpha d alpha. It is representation as a5. Therefore h is equal to, this is nothing but lower limit is alpha 1, upper limit is alpha 2. And according to circuit, therefore the intended angles, lower limit is alpha 1, upper limit is alpha 2. There are subtended angles. Therefore, you have to substitute this equation. Therefore, alpha 1 and alpha 2. Therefore, minus I by 4 pi rho a phi. Therefore, you have to, the cosecant alpha, the cos alpha minus cos alpha, there is representation as cosecant cos alpha 2 minus cos alpha 1. Representation as a plus into a phi. Therefore, h is equal to, finally, the equation is I by 4 pi rho cos alpha 2 minus cos alpha 1 a phi. This is the final expression for a magnetic field intensity in a magnetic field intensity due to straight filamentary conductor. In a straight filamentary conductor, according to Bachelor of Technology, you have two special cases. The two special cases, one case is, the case one, it is a semi-infinite. Semi-infinite. The straight line is a semi-infinite. So what is the value? That point A, it is representation as 0, 0, 0. The point B, it is representation as a 0, 0 minus infinity. Therefore, intended angle alpha 1 is equal to 90 degree. Intended angle alpha 2 is equal to 0 degree. Take substitute this equation, the equation number 6. The substitute equation number 6. Therefore, in special case, semi-infinite, therefore, h is equal to I by 4 pi rho a phi ampere per meter. The case 2, it is infinite length line. For infinite length line, according to the magnitude due to straight filamentary conductor, according to point A, there is nothing but 0, 0, infinite. Point B, 0, 0, minus infinite. Therefore, alpha 1 is equal to 180 degree and alpha 2 is equal to 0 degree. Therefore, take substitute this equation number 6. Therefore, magnetic field intensity H is equal to I by 4 pi rho. There is nothing but cos alpha 2. Alpha 2 is equal to 0. Therefore, alpha 1 is equal to 180. Let's take substitute this equation. There is nothing but 2 a phi. Therefore, the resultant magnetic field intensity H is equal to I by 2 pi rho a phi ampere per meter. The very, very important concept of magnetic field due to straight filamentary conductor. The original expression is H is equal to I by 4 pi rho cos alpha 2 minus cos alpha 1 a phi. And the case 1, for semi-infinite, H is equal to I by 4 pi rho a phi ampere per meter. For infinite length of the line, the straight filamentary conductor, the magnetic field intensity will be changes. H is equal to I by 2 pi rho a phi ampere per meter. This is the, according to Bayard-Savart's law, one of the applications of a magnetic field due to a straight filamentary conductor. Another one, it is a representation as a magnetic field due to a circular loop. For a circular loop, here is the next one, there is nothing but Ampere's circuits law. Very, very important concept in magnetostatic field, Ampere circuits law. In Ampere circuits law states that the line integral of HDL is equal to the net current enclosed by them. This is one of the important basic concept of mathematical equation. The line integral of magnetic field intensity is equal to the net current enclosed by that surface. That is representation as Ampere circuits law. So what is the proof of this Ampere circuits law? According to this equation, there is a circular loop. There is the axis, there is the x-axis, y-axis, along with z-axis. It is a circular loop. It is a rho region. It is the differential element dl. Current I, the differential element dl. It is the magnetic field H along this point. Therefore, rho. It is nothing but a radius. It is nothing but origin point O. It is nothing but the Ampere's law. The circle is, you have to applying it Ampere's law in a circuit. It is nothing but, that path is Empyrean path. The current I along with z direction, the current, that element dl, the current is I into dl. But according to Bayard-Savart's law, for infinite for infinite length line. Already previously I will discuss about this infinite length line. What is the formula? H is equal to I by 2 pi rho A phi. This formula is applicable to the Ampere's circuits law. Therefore, the magnetic field intensity H is equal to I by 2 pi rho A phi. Equation number 1. The above equation 1 to apply the differential element in both sides. Therefore, H into dl is equal to I by 2 pi rho dl A phi. The both sides have to differential element is applied in the above equation 1. Therefore, what is differential element? The differential element along with the rho axis. Therefore, dl is equal to d rho a rho plus rho d phi a phi plus dz az. It's very, very important formula for a cylindrical coordination system. The differential element dl is equal to rho axis, phi axis and z axis. They have to take substitute this equation. Therefore, h into dl is equal to I by 2 pi rho. Therefore, d rho a rho plus rho d phi a phi plus dz az a phi. For this one, there is nothing but a phi. You have to product this one. A rho dot a phi. A rho dot a phi, that is equal to 0. A phi dot a phi. A phi dot a phi is equal to 1. Az dot a phi. Az dot a phi is equal to 0. Therefore, this terminal is equal to 0. You have to eliminate it. The third term is eliminated because of the reason the product of the two dissimilar unit vectors, the dot product is applied. The dissimilar unit vectors, the representation is 0. The similar unit vectors, therefore, similar unit vectors, dot product is applied in similar unit vectors. There is nothing but 1. Therefore, HDL is equal to I by 2 pi rho. Therefore, rho d phi. Rho d phi. Therefore, this equation is 2. The above equation 2 to apply integral. To apply integral in both sides. Therefore, the integral h into dl is equal to I by 2 pi rho d phi. Therefore, rho cancel. Therefore, I by 2 pi rho is constant. Therefore, integral d phi, where d phi is the differential azimuthal angle. The azimuthal angle range is phi is equal to 0 to 2 pi. Therefore, the above equation integral HDL is equal to I by 2 pi integral 0, phi is equal to 0 to 2 pi d phi. Therefore, I by 2 pi is representation as phi over a limits of 0 to 2 pi. Therefore, I by 2 pi into 2 pi minus 0, 2 pi. Therefore, I by 2 pi into 2 pi. Therefore, it is cancelled. There is nothing but current enclosed for a line integral HDL. The proof of the Ampere's circuits law. What is Ampere's circuits law? The line integral of magnetic field intensity is equal to the net current enclosed by them. Therefore, integral HDL is equal to I enclosed. These basic concepts have to point form or differential form of Ampere's circuits law. It is very, very important concept. Point form or differential form. It is nothing but a Maxwell third equation in Magnoto static field. What is Maxwell third equation? The Maxwell third equation state the curl of the magnetic field intensity is equal to current density J. Very, very important. There is a point form of Maxwell equation or differential form of Maxwell equation. The curl of magnetic field intensity is equal to current density J. Therefore, proof. According to Ampere circuits law, there is equation. According to Ampere's circuits law, therefore, the line integral HDL is equal to I enclosed, equation number 1. But we know that I is equal to surface integral JDS in the electrostatic field. Therefore, in I, you have to surface integral JDS, you have to substitute equation number 1. Therefore, the above equation modify. Therefore, the line integral HDL is equal to surface integral JDS. That is the first term, the left hand side equation and the right hand side equation. Therefore, both there is a surface line. The line integral is converted to surface integral. The line integral is converted to surface by using Stokes theorem. What is Stokes theorem? The Stokes theorem states the line integral of ADL is equal to surface integral of del cross A ds. Very, very important. The Stokes theorem. The Stokes theorem is defined as the line integral of a vector A is equal to surface integral of the curl of a magnetic vector field A into ds. Therefore, this formula is applied in left hand side of this equation. Automatically, you have to change surface integral. The surface integral of del cross H ds is equal to right hand side surface integral JDS. Therefore, both will be surface integral. You have to equate them. Therefore, that is del cross H is equal to J. There is the third Maxwell equation. The third Maxwell equation. There is nothing but point form of Maxwell equation. Third Maxwell equation. Therefore, what is the Maxwell fourth equation? Magnoto static field. Before that, therefore, I have to derive the expression for Maxwell fourth equation. Before that, you have to magnetic flux density B. Already you have to define a magnetic flux density. The magnetic flux density B is equal to the flux per unit surface area. The units is Weber per meter square. Also simply B is equal to a differential flux by differential surface area. This is same. So I have to d phi is equal to B into ds. Therefore, phi is equal to surface integral B ds. Very, very important. The flux, magnetic flux is equal to surface integral, the magnetic flux density. Therefore, equation number 1. But in this one, therefore, it is nothing but a magnet. It is nothing but North Pole and South Pole. You have to number of lines will flowing from North Pole to South Pole. North Pole to South Pole, North Pole to South Pole, North Pole to South Pole. The number of lines, there is nothing but flux lines. The flux lines, the number of flux lines, you have to represent as a generate a magnetic flux that is denoted as psi. Therefore, in magnetic flux, the number of lines for unipole, single pole, you have to represent as a 0. Therefore, the total magnetic flux along with a single pole, the magnetic flux is equal to 0 initially. Therefore, phi is equal to 0. So phi is equal to 0, take substitute this equation. Therefore, the surface integral BDS is equal to 0. Very, very important. It is the integral form of Maxwell equation. Integral form of Maxwell fourth equation. This integral form is converted to point form by using a divergence theorem. The divergence theorem is applied in the above equation. The divergence theorem states that the surface integral of ADS is equal to volume integral del dot A dV. This formula is applied this equation. Therefore, the above equation modify. Therefore, volume integral of del dot B dV is equal to 0. That is simply del dot B is equal to 0. There is a point form of Maxwell fourth equation. What is third equation? What is my fourth equation? Then next we have then the point form or differential form, the integral form. There is the Maxwell third equation, Maxwell fourth equation. What is Maxwell third equation? In Maxwell third equation, the curl of magnetic field intensity is equal to current density. What is integral form? The surface integral, line integral, HDL is equal to surface integral, JDS. There is a line integral form of third Maxwell equation. What is the fourth Maxwell equation? Integral form. Therefore, surface integral BDS is equal to 0 per point form. In integral form, therefore, del dot B is equal to 0. Del dot B is equal to 0. This is the for a Magnoto static field. There is the two Maxwell equations. The third Maxwell equation, fourth Maxwell equation. In third Maxwell equation, del cross H is equal to J in point form. Therefore, line integral HDL is equal to surface integral JDS. There is integral form. The fourth Maxwell equation, the surface integral BDS is equal to 0 for point form. The integral form, del dot B is equal to 0. It's a very, very important concept of Maxwell equations. Then first one, there is a electrostatic field. There is a two Maxwell equations, Maxwell first equation and second equation. In electrostatic field, there is the first equation, Maxwell first equation. Del dot D is equal to rho V, the electrostatic field. What is second equation? Del cross E is equal to 0. There is a second equation. There is a Maxwell first equation, electrostatic field. Del dot D is equal to rho V. Second equation, del cross E is equal to 0. Third equation, del cross H is equal to J. Fourth equation, therefore, del dot B is equal to 0. There is integral form. Del dot B is equal to 0. It is nothing but integral form. Surface integral BDS is equal to 0. This one. The very, very important concept in magneto-static field. The two Maxwell equations will be generated pairs. Third Maxwell equation, fourth Maxwell. These Maxwell equations to appear by using different potentials in magneto-static field. Types of potentials in magnetostatic field. What are types of potentials? There are two types of magnetic static potentials. One potential is scalar magnetic potential. First one is scalar magnetic potential, that denoted as Vm. Second one is vector magnetic potential, that denoted as A. First of all, you have to derive the expression and what is the properties of a scalar magnetic potential. It is very, very important. First one is the scalar magnetic potential. First one is scalar magnetic potential, denoted as Vm. The scalar magnetic potential is defined as, therefore in the study case you have to scalar magnetic potential, therefore H is equal to a negative gradient of Vm. Negative gradient of Vm. Therefore, the negative gradient of a scalar magnetic field generate a magnetic field intensity H. So what is the direct definition? What is the direct definition of a scalar magnetic potential? Vm is equal to minus integral A to B H into dl. What are the units of H? The units of H is equal to ampere per meter. What is dl? The dl units is meter. Meter cancel. The units of scalar magnetic potential units is amperes. Therefore, H is equal to minus del Vm. The negative gradient of a scalar magnetic potential gives a magnetic field intensity H. Therefore, the above equation 1 to apply curl in both sides. Apply curl in both sides. Therefore, del cross H is equal to minus del cross del Vm. minus del cross del Vm. We know that the vector identity, the right hand side equation, vector identity del cross del V is equal to 0. Very, very important. In vector identity, del cross del V is equal to 0. Therefore, del cross H is equal to 0. Del cross H is equal to 0? No. Del cross H is equal to J according to Maxwell's third equation. Therefore, the scalar magnetic potential exists. Therefore, del cross H is equal to 0. Therefore, according to Maxwell's third equation, del cross H is equal to J. There is a second equation, there is a third equation. You have to compare. Current density is equal to 0. The scalar magnetic potential defined, it is exist in a region, current density J is equal to 0. Very, very important concept. In a scalar magnetic potential, no doubt about it, there is a negative gradient of a scalar magnetic potential gives magnetic flux density. Directly you have to define the minus negative integral of HDL gives, there is a scalar magnetic potential. The scalar magnetic potential exists. Therefore, J is equal to 0. J is equal to 0. Next one, it satisfies a Laplace equation. What is Laplace equation? The Laplace equation del square V is equal to 0. There is a Laplace equation. Laplace equation del dot del V is equal to 0. The divergence of gradient of potential V is equal to 0. There is nothing but a Laplace equation. But in this Laplace equation, to satisfy scalar magnetic potential or not. Next one, there is a, we know that B is equal to mu H. B is equal to mu H. Therefore, del dot B is equal to mu into del dot H. Therefore, dot product is applied in both sides. Therefore, del dot B is equal to mu into del dot H. Therefore, 1 by mu del dot B is equal to del dot. What is H? H is equal to minus del Vm. There, take substitute this equation, minus del Vm. Therefore, in this one, del square Vm is equal to minus 1 by mu del dot B. But we know that del dot B is equal to 0 according to Maxwell. According to Maxwell fourth equation. Therefore, del dot B is equal to 0. Therefore, del square Vm is equal to 0. It is satisfy Laplace equation. So what is the important properties? Important properties of scalar magnetic potential. The first property you have to define. Therefore, a negative gradient of scalar magnetic potential gives a magnetic field intensity H. That is the first point. Second point, the scalar magnetic potential exists. The current density J is equal to 0. That is the second property. Third property, it will satisfy a Laplace equation. Third point, it will satisfy Laplace equation del square V is equal to 0. What is the fourth point? The fourth point, the direct definition of scalar magnetic potential Vm is equal to minus integral A to B H into dl. What is the fifth property? The fifth property, most of the important property, the potential. Potential units is generally in volts. But in this one, there is a scalar magnetic potential, the unit is amperes. These are the important properties of a scalar magnetic potential. The first property is equal to minus del Vm. Second property, the scalar magnetic potential exists at J is equal to 0. Third property, therefore satisfy Laplace equation del square V is equal to 0. Therefore, third, you have to directly the scalar magnetic potential define Vm is equal to minus integral A to B H into dl. The last property, there is nothing but the unit is amperes. Units is amperes. There is the first. There is a this is the story about that scalar magnetic potential. Next one is vector magnetic potential A. This next heading, vector magnetic potential. Vector magnetic potential. First one, the important concept is what is vector magnetic potential. The vector magnetic potential, the curl of vector magnetic potential gives a magnetic flux density. It is very, very important. Therefore, where A is the vector magnetic potential, units is Weber per meter. Units is Weber per meter. What is the magnetic flux density? What is the relation between the vector potential? Therefore, the curl of vector magnetic potential gives a magnetic flux density B. మరి వెక్టార్ మ్యాగ్నెటిక్ పొటెన్షియల్ ఇన్ ఏ లైన్ కరెంట్. A in a line current. You have to one of the important derivation of vector magnetic potential. Therefore, the differential vector magnetic potential dA is equal to directly proportional to I into dl and inversely proportional to R. Very, very important. Therefore, this one dA is equal to mu idl by 4 pi R. Therefore, A is equal to mu by 4 pi integral idl by R. Equation number 1. What is units? Weber per meter. Units is Weber per meter. You have to derive the expression. Proof. Therefore, in a line current, you have to calculate vector magnetic potential is directly proportional to product of the into dl and inversely proportional to the distance between them. The distance is the source point to field point distance. Source point to field point distance. Suppose you have to denote it as H. H is equal to a line integral idl cross AR by 4 pi R square according to Biot-Savart's law. According to Biot-Savart's law. We know that B is equal to mu H. Therefore, H is equal to this equation. Take substitute this one. Therefore, equation number 1, substitute equation number 2. Therefore, B is equal to mu integral mu idl cross AR by 4 pi R square. That is equal to mu by 4 pi line integral idl cross AR by 4 pi R square. This is the equation number 2. What is R? Where R is the distance from source point to field point. This is the source point. This is the field point. This is a line joining them. This source point representation as x dash, y dash, z dash. This is the field point. This is the field point. This denoted as x comma, y comma, z. You have to distance R. Therefore, this is the position vector R. This is the position vector R dash. It is origin point. Or what is R? R is equal to R minus R dash. You have to find out R. Or what is R? Source point to distance of field point. The distance is R. Therefore, according to calculate R. Therefore, R is equal to x minus x dash AX plus y minus y dash AY plus z minus z dash AZ. What is the magnitude of R? The magnitude of R is equal to x minus x dash whole square plus y minus y dash whole square plus z minus z dash whole square whole power 1 by 2. My ambition is R by R cube. My ambition is AR by R square. AR by R square. Therefore, you have to find out R by R cube is equal to x minus x dash AX plus y minus y dash AY plus z minus z dash az by, therefore, x minus x dash whole square plus y minus y dash whole square plus z minus z dash whole square whole power 1 by 2, 3 by 2, whole power 3 by 2. This is equal to minus del into 1 by r. It's very, very important. R by r cube. Therefore, r by r cube means ar by r square, that is equal to r by r cube, that is equal to minus del 1 by r. Equation number 3. This equation is substitute equation number 2. 2, it is nothing but 3. Equation number 4. This is nothing but equation number 4. Therefore, equation number 4, substitute equation number 3. What is 3? Therefore, B is equal to mu by 4 pi integral I dl AR by R square. AR by R square means minus, therefore minus 1 by R. Very, very important. Equation number 5. First of all, you have to find out dl cross del 1 by R. Very, very important. You have to substitute this equation according to vector identity. Therefore, del cross f. What is the formula of del ff? Therefore, f del cross capital F plus del f cross capital F. Therefore, where f is the scalar quantity, where capital F is the vector quantity. Therefore, take f is equal to 1 by r, capital F is equal to dl. Take substitute this above equation. Therefore, del cross, therefore f is 1 by r, therefore dl by r is equal to, therefore 1 by r del cross dl plus del f, del 1 by r cross f means dl. My ambition is this one, therefore del 1 by r cross dl is equal to del cross dl by r minus 1 by r del cross dl. Therefore, this one I have to interchange. What it means? dl cross del 1 by r. dl cross del 1 by r. Del 1 by r. That is equal to, you have to reverse, minus del cross dl by r plus 1 by r del cross dl. But in this one, del cross dl, where del is varies from a source point x comma y comma z along with figure, there is nothing but x comma y comma z. Next, dl is a vector field, varies from a field point. Therefore, field point x dash, y dash, z dash. Therefore, del cross dl is equal to 0. Because of the reason, del is nothing but it varies from source point, dl varies from field point. Therefore, these two, it is representation as a curl is applied in between del or dl. This representation as 0. Therefore, del cross dl is 0. Therefore, what is this one? dl cross del 1 by r is equal to minus del cross dl by r. They take substitute this. Equation number 6. Equation number 6 substitute equation number 5. What is 5? Therefore, b is equal to mu by 4 pi integral I dl minus I dl cross del 1 by r. What is dl cross 1 by r? You have to representation as dl cross del 1 by r, equation number 5. But dl cross del 1 by r gives minus del cross dl by r, equation number 6. Take substitute this equation. Therefore, b is equal to minus mu by 4 pi integral I dl delta cross this one. Therefore, what is this one? Minus del cross dl by r. Therefore, minus of minus plus. Therefore, del cross mu by 4 pi integral I dl by r is nothing but b. Equation number 7. What is the first equation? B is equal to del cross A, equation number 1. Therefore, the curl of vector magnetic potential A gives a magnetic flux density B. You compare those two equations, equation number 7 and 1. What is A? The vector magnetic potential A is equal to integral mu ideal by 4 pi r Weber per meter. It's very, very important. A vector magnetic potential. For vector magnetic potential satisfy a Poisson's equation. Next, you have to Poisson's equation. In electrostatic field, what is the Poisson's equation? In electrostatic field, the Poisson's equation del square V is equal to minus rho V by epsilon. It is the Poisson's equation. But in this one, there is a magnetostatic field. In a scalar vector magnetic potential satisfy Poisson's equation or not? Already, you have to scalar magnetic potential satisfy Laplace equation. But in this vector magnetic potential satisfy Poisson's equation or not? First of all, you have to Poisson's equation satisfy or not? First of all, therefore, according to Maxwell third equation, del cross H is equal to J. Therefore, H is equal to del cross B is equal to mu H. Therefore, H is equal to B by mu. Therefore, B by mu is equal to J. Therefore, del cross B is equal to mu J. Therefore, B is equal to del cross A. Take substitute this one. B del cross A is equal to mu J. What is del cross A? In vector identity, del cross A is equal to del dot A minus del square A is equal to mu J. Mari del dot B is equal to 0 according to Maxwell fourth equation. For what is B? Del dot del cross A is equal to 0. That is del dot A is equal to 0. Therefore, in this equation, del dot A is equal to 0. Therefore, minus del square A is equal to mu J. Therefore, del square A is equal to minus mu J. It is satisfy Poisson's equation. What is Poisson's equation? Electrostatic field. In electrostatic field, Poisson's equation del square V is equal to minus rho V by epsilon. But in vector magnetic potential, therefore, in electromagnetostatic field, the vector magnetic potential gives, it satisfy a Poisson's equation del square A is equal to minus mu J. Therefore, in this one, where J is the current density if J is equal to 0, the above equation. For what is this one? Del square A is equal to 0. Therefore, the vector magnetic potential also satisfy Laplace equation. First of all, what is the properties or characteristics? Properties of vector magnetic potential A. The first property, the curl of vector magnetic potential gives a magnetic flux density. That is the first point. Second point, the vector magnetic potential A directly proportional to current density Z. Third point, it satisfies Poisson's equation. Note, therefore, most probably the vector magnetic potential used in radial component in antennas. In antenna wave propagation, there is a next semester in antennas. Therefore, vector magnetic potential important criteria to find out a radial component in free space by using vector magnetic potential A. Therefore, in antennas, vector magnetic potential is used in radial component. These are the important properties of a vector magnetic potential. First point is the curl of vector magnetic potential gives a magnetic field intensity. The second point, the vector magnetic potential A directly proportional to current density. Third point, it satisfies a Poisson's equation. First of all, there is a scalar magnetic potential, one of the important point in GATE 2015. One problem is there. Therefore, H is equal to 1 by rho A phi. Therefore, rho is in between 1 to 2 meter and phi is range from 0 to 2 pi and Z is range from 0 to 2 meter. What is the find out a vector scalar magnetic potential Vm at 4, 50 degree and 2. This is one of the important problem in the GATE 2005. But what is the formula? What is the solving of this above problem? There, by using this vector scalar magnetic potential Vm is equal to minus integral H dl. Now what is H? Given data, H is equal to 1 by rho A phi. Therefore, minus integral 1 by rho A phi. Or what is dl? In dl, rho phi z. What is rho phi z? In coordination system, rho phi z is cylindrical. The cylindrical coordination system. In cylindrical coordinate system, rho phi z. Therefore, the differential element dl is also a cylindrical coordinate system. D rho a rho plus rho d phi a phi plus dz az. Therefore, this one equation number Vm is equal to equation number 1, equation number 2. Therefore, equation number 2 substitute equation number 1. Therefore, Vm is equal to minus integral 1 by rho A phi. dl means this one is a dl. dl means this one. Therefore, d rho a rho plus rho d phi a phi plus dz az. Therefore, a phi dot a rho dissimilar unit vectors 0. A phi dot a phi similar unit vectors, that is equal to 1. Dissimilar unit vectors a phi dot az is equal to 0. Only the two terms will be neglected. Only this term will be appear. Therefore, above equation. Therefore, Vm is equal to minus integral 1 by rho. What is dl? dl is equal to rho d phi. Therefore, rho cancel. Minus integral d phi. Integral, it is differential. Derivative is cancel. Therefore, minus 5. What is the value? Vm. The vector magnetic potential, scalar magnetic potential, Vm is equal to minus 5. But if I have to find Vm at 4, 50 degree and 2. What is 50 degree? Rho phi z. What is the value of phi? Phi is equal to 50. Take substitute this equation. Minus 50 degree. Vm units is amperes. Where Vm in terms of degrees. Therefore, the degrees converted radians. Therefore, minus 50 into pi by 180. Therefore, I have to cancel. Therefore, approximately minus 0.8716 amperes. That is the Vm. The very, very important problem in GATE 2015. Next one. This is the same. This is another problem. The GATE 2013. There are scalar magnetic potential A, vector magnetic potential A. You have to find out. In this one, you have to find out value of A. B cross A. A is equal to minus rho square by 4 Az Weber per meter. Phi is equal to pi by 2. Rho 1 less than rho less than 2. 0 less than z less than 5. To calculate flux phi. To calculate phi. Flux. Find out flux. GATE 2013. For what is the value of a vector magnetic potential A is equal to minus rho square by 4 Az Weber per meter. Now what is the solve? We have to problem by using finally magnetic flux phi. Answer. This one, first of all, you have to find out A, Az. First, you have to find out B. B is equal to del cross A. Del cross A means, therefore, B is equal to del cross A. You have to det according to Z, A rho, A phi, Az. Next, dou by dou rho, dou by dou phi, dou by dou Z. What is aero component? The aero component is 0. This is one Az component. Therefore, this is 0. Az component only minus rho square by 4. You have to det, you have to solve them. According to B is equal to del cross A. Therefore, B is equal to del cross A. B is equal to del cross A. That is equal to A rho, A phi, Az, dou by dou rho, dou by dou phi, dou by dou Z, 0, 0, minus rho square by 4. First of all, you have to find out B. Therefore, first of all, aero component. Aero component, what is that? Dou by dou phi minus rho square by 4. That's the first point. This one 0. Next one, minus A phi. Minus A phi. This component. Dou by dou rho minus rho square by 4. Third component, plus Az. Plus Az, third component, 0, 0. Therefore, last point is 0. Therefore, this one, B is equal to dou by dou phi minus rho square by 4. Aero. And in this one, minus of minus, plus. Dou by dou rho, rho square by 4. A phi. Last term is 0. But in this one, you have to differentiate with respect to phi. But in this one, this is a rho component. With respect to phi, there is no phi component. This component is always 0. That the first term is 0. But what is term? The B is equal to only dou by dou rho, rho square by 4. A phi. Therefore, you have to differentiate. Therefore, differentiate 2 rho by 4 A5. What is the component? Rho by 2 A5 Weber per meter square. ఎందుకంటే మనం we have to find out a magnetic field flux density. B is equal to rho by 2 A5 Weber per meter square. First of all, you have to find out flux. Flux phi. Flux phi. Therefore, flux according to Maxwell fourth equation, phi is equal to surface integral BDS. Surface integral BDS. Therefore, surface integral B means rho by 2 A phi. What is ds? Where ds is the data about that phi rho z. Therefore, ds is equal to d rho. It is variable 1 to 2. D rho. It is variable 0 to 5. dz A phi. It is ds. What is ds? ds is equal to d rho dz A phi. Therefore, A phi dot A phi 1. This you have to similar for similar unit vectors that is equal to 1. Therefore, surface integral rho by 2 d rho dz. Therefore, what is 1? 1 by 2 rho d rho dz. What is rho? Rho is a variable component. Variable component which 1 to 2, 0 to 5. Therefore, 1 to 2, 0 to 5. Therefore, 1 by 2. This is nothing but we have to integrate rho square by 2. Upper limit is 2, lower limit is 1. It is dz. Z. Upper limit is 5, lower limit is 0. Take substitute this equation. 1 by 2. Therefore, psi is equal to 1 by 2 rho square by 2 1 to 2 z 0 to 5. Therefore, phi is equal to 1 by 2 upper limit 4 by 2 minus 1 by 2. This one 5 minus 0. Therefore, phi is equal to 1 by 2 2 minus 1 by 2 into 5. Therefore, phi is equal to 1 by 2 4 minus 1 3 by 2. This is 5. Therefore, phi is equal to 1 by 2. 5 3s are 15 by 2. Therefore, phi is equal to 15 by 4. Phi is equal to 3.75 Webers. It's a very, very important problem in GATE 2013, 2015. These concepts are the very important concepts in magnetostatic fields. So another one, you have to derive the expression for magnetic field intensity in a circular loop. You have to find out circular loop. The forces due to magnetic field are an important concept in the Bachelor of Technology. First one is the forces in magnetostatic field. Different types of forces. And the first one is the force on a charged particles. Second one is the force on a single current element. The third one is force between two current elements. The forces due to magnetic field. The first one is force on a charged particle. దీన్ని large force equation. Second one is force on a single current element. Third one is force between two current carrying elements. This section will continue in the next stage, the force due to magnetic field. First of all, today class is today class is a magnetostatic field. What is magnetic field? What is magnetic field intensity? What is magnetic flux density? And what is important in everyone in an electromagnetic field theory? Everyone is very important, including with units. The phi, the flux, electric flux, magnetic flux units is Weber, 1 average over 10 to the power of 8 lines. Each and every point you have to very important concepts in gate point of view and Bachelor of Technology to E-set point of view and gate point of view. All very, very important concepts in electromagnetic waves and antennas. Therefore, magnetic field intensity, magnetic flux density. Therefore, the second one is you have to Weber per meter square or Tesla. Therefore, Bayard-Savart's law, I have to directly proportional to ideal sin theta by r square. The proportionality constant k is equal to 1 by 4 pi. Therefore, A cross B is equal to mod A mod B sin theta. Therefore, next concept is DH is equal to ideal cross AR by 4 pi r square. AR is equal to R by 1 by R. Therefore, R by ideal cross R by 4 pi r cube. Newton per Weber or ampere per meter. Very, very important units in magnetic field intensity. The magnetic field intensity is line charge, line current. Therefore, magnetic field intensity in surface current, magnetic field intensity in volume current. Therefore, line current, surface current and volume current, ideal is equal to KDS is equal to JDV. Next one, magnetic field due to straight filamentary conductor. According to Bayard-Savart's law, there is a straight filamentary conductor. According to straight line, there is a origin point, there is a point P. You have to determine DH at point B. Therefore, according to Bayard-Savart's law, DH is equal to ideal cross AR by 4 pi r square Newton per Weber or ampere per meter. DH is equal to ideal cross R by 4 pi r cube. Then according with DL, along with straight filamentary conductor, DL is equal to dz az, R is equal to rho a rho minus z az. The minus you have to indicate you have to downward direction, or you have to minus z az. Magnitude of R is equal to this one. Therefore, according to that, you have to curl in DL cross R. This one you have to pay according to by using a subtended angles alpha 1, alpha 2, alpha. Therefore, cot alpha is equal to z by rho, z is equal to rho cot alpha. They have to take substitute this equation. Therefore, differential element. Therefore, h is equal to finally h is equal to I by 4 pi rho cos alpha 2 minus cos alpha 1 a phi. In a special case, you have to semi-infinite. There these points will be applied in the equation. H is equal to I by 4 pi rho a phi ampere per meter. Case 2, it is infinite length line. Therefore, you have to substitute this equation. Therefore, you have to find out magnetic field intensity. H is equal to I by 2 pi rho a phi ampere per meter. And next important concept is Ampere circuits law. In Ampere circuits law, what is Ampere circuits law? The statement of Ampere circuits law. The line integral of magnetic field intensity HDL is equal to I enclosed. But what is the proof of this Ampere circuits law? It is a circle, the concept of along the z direction, the current flowing in I, the element in DL, therefore I into DL, there is a magnetic path line in a circle. Therefore, there is nothing but Amperean path. Therefore, according to Bayard-Savart's law, for infinite length line H is equal to I by 2 pi rho a phi. Therefore, HDL is equal to I by 2 pi rho DL a phi. Where DL is equal to, along with a cylindrical coordination system, d rho a rho plus rho d phi a phi plus dz az. Take substitute this equation. You have to, according to these dot product properties, these two will be eliminated. Therefore, I by 2 pi rho d phi. Therefore, integral HDL is equal to this one. Rho cancel. Therefore, I by 2 pi rho. Next one is, therefore, integral HDL is equal to I enclosed according to Ampere circuits law. What is Ampere circuits law? Therefore, integral of magnetic field intensity DL is equal to the net current enclosed by them. These Ampere circuits law in point form of or differential form of Ampere circuits law. This is a Maxwell third equation. Therefore, del cross H is equal to J. Therefore, what is del cross according to Ampere circuits law? HDL is equal to I enclosed. We know that I is equal to surface integral JDS. Therefore, substitute this equation. The line integral HDL is equal to surface integral JDS. Therefore, this is surface integral. This is line integral. This is not equal, but it is equal. Therefore, line integral is converted to surface integral. The line integral is converted to surface integral by using Stokes theorem. What is Stokes theorem? The line integral of vector field A dl is equal to surface integral. The curl of a surface vector magnetic field A of a curl of surface. This is nothing but a Stokes theorem. The applied in the above equation. Therefore, surface integral del cross H ds is equal to surface integral JDS. Therefore, del cross H is equal to J. There is a point form or third Maxwell equation. Therefore, you know that Maxwell magnetic flux density B is equal to 5 by S Weber per meter square. B is equal to d5 by ds. Simply have to differential flux by differential surface area. Therefore, d psi is equal to B into ds. Psi is equal to surface integral BDS. In a surface integral BDS, therefore, in a single magnetic flux, every magnetic line will flowing from north pole to south pole. This is a number of magnetic lines will south to north pole to south pole. That lines are called Weber. The flux will be generated. In a single pole, in one monopole, the flux will be initially generated. That flux will be initially 0. Therefore, psi is equal to 0. Therefore, psi is equal to 0 is applied in the above equation. Therefore, surface integral BDS is equal to 0. That is the integral form of Maxwell equation. You have to the above equation, the divergence theorem applied. What is divergence theorem? The surface integral of the magnetic vector ds is equal to volume integral del dot A dv. They applied in left hand side equation. The volume integral del dot BD dv is equal to 0. Therefore, del dot B is equal to 0. Point form of Maxwell fourth equation. What are the summary of the Maxwell equations in the point form, in integral form, in Maxwell third equation, Maxwell fourth equation, in Magneto static field. In point form or differential form, the Maxwell third equation is del cross H is equal to J, already proved. Therefore, in Maxwell fourth equation, therefore, according to point form, del dot B is equal to 0, already have to prove. For integral form, the line integral HDL is equal to surface integral JDS in integral form. In Maxwell fourth equation integral form, surface integral BDS is equal to 0. There is the conversion of magnetic flux density. Conversion of magnetic flux density should be equal to 0. In electrostatic field, Maxwell equation 1, in Maxwell equation 2, in Maxwell equation 1, del dot D is equal to rho V, in Maxwell equation 2, del cross E is equal to 0. These are two equations. Therefore, overall, there is a 4 equations. Maxwell first equation, Maxwell second equation, Maxwell third equation, and Maxwell fourth equation. There is a 4 equations in electrostatic field and magnetostatic field. Next one is types of potentials in magnetostatic field. The first one is scalar magnetic potential. Second one is vector magnetic potential. And scalar magnetic potential denoted as Vm. Vector magnetic potential denoted as A. The scalar magnetic potential Vm gives, the negative gradient of Vm gives a magnetic field intensity H, where H is equal to minus del Vm. Therefore, directly how to define Vm is equal to minus integral A to B H into dl. Therefore, equation number 1, to apply curl in both sides, del cross H is equal to minus del cross del Vm. Therefore, del cross H is equal to 0. Del cross del V is equal to 0 according to vector identity. Therefore, del cross H is equal to 0, but according to Maxwell third equation, del cross H is equal to J. But del cross H is equal to 0, del cross H is equal to J. You have to compare those two equations, J is equal to 0. Therefore, the scalar magnetic potential Vm is exist in a region when J is equal to 0. Therefore, units is H is units is ampere per meter, dl units is meter, meter cancel. The H is the Vm units is ampere. According to the scalar magnetic potential to satisfy Laplace equation or not. What is Laplace equation? In Laplace equation, the divergence of the gradient of vector field V is equal to 0. There is a Laplace equation. Del square V is equal to 0. Therefore, you know that B is equal to mu H. Therefore, dot product is applied in both sides. Del dot B is equal to mu into del dot H. We know that H is equal to minus del Vm. Therefore, we know that del dot B, mu, this one, 1 by mu del dot B. del dot minus del Vm. Therefore, del square Vm is equal to minus 1 by mu del dot B. Therefore, del dot B is equal to 0 according to Maxwell's fourth equation. Therefore, del square Vm is equal to 0 to satisfy Laplace equation. What are the important properties of scalar magnetic potential? For the first point, the negative gradient of scalar magnetic potential gives a magnetic field intensity H. Therefore, the scalar magnetic potential exists when J is equal to 0. The scalar magnetic potential satisfies Laplace equation, that is del square V is equal to 0. The direct definition, therefore, direct scalar magnetic potential Vm is equal to minus integral H into dl. The last one, therefore, the important property, the scalar magnetic potential units are amperes. Next one, there is vector magnetic potential A. The vector magnetic, the curl of the vector magnetic potential gives the magnetic field intensity, magnetic flux density B. Therefore, units is Weber per meter. Therefore, in a line current, the magnetic, the differential magnetic vector magnetic potential dA is directly proportional to I into dl and inversely proportional to distance between the source point to the field point. Therefore, A is equal to mu by 4 pi integral I dl by r. Equation number 1, it is Weber per meter. Then prove this one. We know that according to Bayes-Savart's law, H is equal to line integral I dl cross AR by 4 pi r square. Equation number 1. B is equal to mu H. Take substitute this equation. This source point to field point. Next one, there is R. You have to magnitude of R by R cube. AR by R square is equal to R by R cube minus delta 1 by R. Take substitute this equation. You have to important vector identity formula. Therefore, these formula you have to substitute this equation. Mu by ideal cross. Therefore, you have to compare these two equations. Compare. These you have to two equations are compare. They're compare. Therefore, A is equal to integral mu ideal by 4 pi r Weber per meter. A very, very important concept in vector magnetic potential. In vector magnetic potential satisfy a Poisson's equation. In electrostatic field, the Poisson's equation states del square V is equal to minus rho V by epsilon. Therefore, in this one, you have to satisfy it. First of all, you have to Maxwell third equation, del cross H is equal to J. Therefore, B is equal to mu H. H is equal to B by mu. Therefore, del cross B by mu is equal to J. Del cross B is equal to mu J. Therefore, B is equal to del cross A. Take substitute this equation. Del cross A, according to vector identity, del dot A minus del square A is equal to mu J. Therefore, del dot A is equal to 0 because del dot B is equal to 0. Del cross B is equal to 0. That is del dot A is equal to 0. Take substitute this equation. Minus del square A is equal to mu J. Therefore, minus del square A is equal to mu J. Del square A is equal to minus mu J is satisfy a Poisson's equation. In magnetostatic field, the del square A is equal to minus mu J. If the above equation J is equal to 0, del square A is also 0. Therefore, vector magnetic potential also satisfy Laplace equation. The important properties of vector magnetic potential. The first of all, the curl of vector magnetic potential gives a magnetic flux density B. Next one, therefore, the magnetic vector potential A directly proportional to current density according to the Poisson's equation. It satisfies a Poisson's equation. An important note, therefore, vector magnetic potential used in the radial component in antennas. Next one, in GATE 2025, you have to problem is given, you have to calculate Vm, you have to some problem, you have to calculate Vm. Therefore, Vm is equal to finally, the answer is minus 0.8716 amperes. Important formula. GATE 2013, you have to important formula is there. You have to calculate flux. There you have to find out flux. This is the concept. Finally, I have to 3.75 Webers. Therefore, next slide. I have to force due to magnetic field. The force due to magnetic fields are classified three types. The force on a charged particles, large force equation. Therefore, force on a single current element, force between two current elements. The C, you have to discuss about this next class. You have to force due to magnetic field. It is very, very important concepts in today session, electromagnetic fields and transmission lines. This subject is a very tough feeling, but the subject is very easy. The basic concepts are very important in magnetostatic and electrostatic field. In the first unit, the electrostatic field. Second unit is magnetostatic field. In Both electric and magnetic fields are combined with time varying field. And next one is electromagnetic field theory properties, propagations. Last one is transmission lines. The very important concept. Next concept, you have to explain about that force due to magnetic field. Okay, thank you.